Alright, for problems 3 through 5 on the practice test, we are going to see whether or not each system is either inconsistent, dependent, or independent. And remember that inconsistent systems have no solution. Well, what gives us no solution? It's going to be parallel lines. Dependent systems are going to be one line on top of the other. So what gives us that? It gives us infinite solutions. And then independent systems have one solution. So if I graph those, what does a no solution system look like? Well, if you graphed it, it's going to be two parallel lines that never touch. If they never cross, they never have a solution. An infinite system is going to be a graph where one line is on top of the other. So what allows us to have that? Well, it has to be the same equation. That's what gives us a dependent system. And then, of course, a system that has one solution is any two lines that cross at one point. So that's a review real quick of inconsistent, dependent, and independent systems. So let's go ahead and see what each system here is going to be. So if I look at problem number 3, what I have is negative 3x plus y equals 4 and 6x minus 2y equals 6. So neither one of these are going to be in slope-intercept form. So what I want is I want to be able to put each one of these into slope-intercept form. I want to get y by itself. So if I add 3x to each side, that gets y by itself on the left-hand side, which is what I want. So my first equation is y equals 3x plus 4. My second equation, the 6x minus 2y equals 6, I want to be able to get x by its, or sorry, excuse me, I want to be able to get y by itself again. So I'm going to subtract 6x from each side. Sorry about that. That was the announcements that just came on. If I subtract 6x from each side, I've got negative 2y equals negative 6x plus 6. And to get rid of that negative 2 that's being multiplied to the y, I'm going to divide both sides by negative 2. And that leaves me with y equals 3x minus 3. So that's the second equation in slope-intercept form. So looking at both equations, I can tell right away that they have the same slope. I can also tell that each one has two different y-intercepts. I know that those will make parallel lines that will never touch because of the same slopes and different y-intercepts. So if they never touch, that is going to be an inconsistent system. Alright, does that kind of make sense? If I put both of those on a graph, I'm going to have a y-intercept in the positive side of 4. And then I'm going to have a y-intercept for the other one of negative 3 on the negative y-intercept side. And they're going to look something like that. They're never going to touch. They're an inconsistent system. So if I look at number 4, I want to be able to get y by itself. So let me take 2x plus 3y equals 1. And let me subtract 2x from each side. And I'm left with 3y equals 1 minus 2x. And if I divide both sides by 3 to get y by itself, I'm going to end up with, let's put my x term first, so negative 2 over 3x. And then my y-intercept is positive 1 over positive 3, which is positive 1/3. So that's my equation in slope-intercept form. For my second equation, 4x plus y equals negative 3. Again, I want to subtract 4x from each side to get y by itself. There's nothing to divide here. I just have y equals negative 4x minus 3. Again, I look at the slopes. Both slopes are different. So anytime I have different slopes, regardless of the y-intercepts, it's going to be two lines that cross. I know that in that case that I have an independent system of equations. All right, and then finally, you've got y equals 2x minus 3. So the first one is already in slope-intercept form, nothing to do. The second equation, I want to get y by itself by subtracting 6x from each side. And if I divide both sides by negative 3, that's going to leave me with y equals, let's put my x term up front first, so negative 6 divided by negative 3 is going to give me a positive 2x. And positive 9 divided by negative 3 is going to be negative 3. So looking at both equations, y equals 2x minus 3 and y equals 2x minus 3, I have the same slope, same y-intercepts. I know that if I graph them, it's going to be one line on top of the other. So if it's one line on top of the other, they're touching each other everywhere. There's an infinite number of solutions. I know based on that I have a dependent system. And I hope that helps. Review your notes if you're not sure how to tell if something is one solution, no solution, or infinite number of solutions.